Welcome to today's webinar entitled Designing and Constructing Natural Grass Athletic Fields, Key Considerations for Success. My name is Billy Zadig, Manager Special Programs for APA. Just a couple of housekeeping items before we get started. The webinar recording will be posted to the APA webpage under the Continuous Learning tab later today. Professional continuing education certificates are being offered for today's program. Those who indicated they wanted a certificate at registration and meet the requirements will receive certificates later this afternoon. All attendees are in listen-only mode. Please type your questions in the chat box and they will be answered in the order they are received. If we run out of time and we still have questions, responses will be sent directly to the person asking the question by our presenter. Before we get started, I'd like to take a moment to introduce our speaker, Peter Spanos. Peter is a Senior Project Manager for Gale Associates, specializing in athletic facilities planning and design, including synthetic turf, athletic track, field, and event layout, site drainage analysis, utility relocation, road layout, water and wastewater systems, parking lot layout, and flood mitigation. He provides engineering and design services related to land development, use, and permitting. Pete is a member of the American Sports Builders Association and a certified floodplain manager. At this time, it's my pleasure to turn this over to Pete Spanos, our speaker for today's webinar. Pete, take it away.
Thank you, Billy. Thank you for the great introduction. So today we're going to be speaking about and discussing design and construction of the natural grass athletic fields and some key considerations to take away. So, sorry about that. So, we'll try to split up the presentation in kind of several parts: evaluation, design, construction, maintenance, and budget, and try to touch base a little bit on each one of these. The evaluation portion, we'll touch base on whether taking a look at it from an existing athletic facility, an existing natural grass field that's been having some issues, and you want to see what you can do about making the improvements and renovating it in kind. And then in the design portion, we will talk about things that you can do to create a new natural grass field from the start, or what you could do to modify the existing field to make it perform better and out at an optimal level. The construction process, some of the maintenance requirements, and briefly touch base on some of the budgetary items. Each one of these we can separate and hold a whole session on for each one of these, but I'll try to kind of keep this moving along. So evaluation. So right here, it always starts with a site evaluation, right? What do you have, right? What are your existing facilities? And the first one is whether it's the facility manager or the staff or the coaches and players, the visual observations. What do you see? They're one of the first ones to see what's going on. Do we have drainage problems? Do we have planarity issues? Is there something going on with patches of grasses that are either void from being worn out from excessive use, or have some type of disease going on, or things of that nature? The next steps always, if you don't have it, is to perform an existing conditions topographic survey. If you're seeing that you have issues and you're seeing that you want to make these improvements, whether it's going to be a brand new field or a renovation, you want to take the guesswork out of it. So you really want to spend the money up front to perform an existing condition survey that will tell you, to scale all the limits of where your walkways are, your perimeter fencing, what the drainage and utilities are, but most importantly, it'll tell you what the topography is, how this thing drains. Do we have planarity issues? Do we have low spots within the field? This always helps that out. So geotechnical investigation is the next one, and what I mean by that is to do soil characteristic, a soil texture analysis. You see there the little triangle pyramid there, and you see the wedge sample that was taken out. You kind of want to see what's going on underneath there. Once you get past the plant growth material in the root zone, you're getting into the native soils that are in there. And are we talking about a more of a clay soil, more of a silty soil? That will dictate, how well you're able to drain this field vertically rather than just relying on surface drainage, which I'll talk about in the upcoming slides. And along with that is soil testing. Soil testing for the nutrient management. The whole slew, the whole battery of tests there, where you are with the macronutrients, the pH levels, things like that. And then evaluating your stormwater drainage system. Are you just relying on just having everything sheet flow to perimeter swales around your natural grass fields? Do you actually have under drains? Do you have catch basins in the corner? Are they silted up? Have they ever been cleaned out? Have the pipes been cambered? Things like that, right? If you're in an area that's subjective, as more and more people are getting flashier and more heavier and longer precipitation events, depending on where you are in the region, your area could tend to flood, and you want to be able to, once that happens, to be able to drain it and dry it out as quickly as possible so you can keep getting on there. And then your existing irrigation system, right? How is it working? Are the zones all right? Is the coverage the way you want? Do you have the proper pressure with your irrigation heads? Or are you getting those, those famous little donut patterns, little green circles around each head, and then the rest is kind of brown from, usually an indication that you don't have proper pressure. And we get into the design, right? For the most part here, we're going to be concentrating on the kind of what happens on the interior limits of the natural grass field, whether it's a rectangular multi-purpose field or a baseball field. For the purposes of this webinar, I'm not really going to talk about perimeter fencing and accessibility grandstands, athletic lighting, things like that. But they're always a consideration when you're spending the money to make improvements on your natural grass field. You also want to look at whether you need to make upgrades of the adjoining amenities that go with your field. So this is just taken from the ASBA fields manual. Is just the rule of thumb on different dimensions. For the purposes of this, we want to concentrate on the college level, the NCAA level, and more of the higher end type of limits. Most of them do have ranges with optimal limits for each one. It all depends on your site constraint, right? What can you fit in the area that's there? But also you want to be mindful of that second bullet there, the safety runout areas. And that's basically having an unobstructed free zone of natural grass at the same slope. You don't want to change the grade on it after you leave the playing limits of the soccer, football, whatever it is. You want to make sure you have at least 10 feet minimum of safety runout area. So next slide here is we're talking kind of similar situation here, but for baseball and softball fields. Again, the baseball and softball can get dictated. There's a whole slew of ranges that can happen. And they're all recommendations, right, for baseball for different types of outfield links. But typically we want to, if we can get it, stay within 330 in the foul lines to 400 in the center. The main rule of thumb with baseball is the distance, right? From the mound to the home plate elevation, 10 inches. Can't be more, can't be less. And then after that, we're talking about best fit and recommendations that can go from there. And then with college as well, depending on type of fencing you have, it can dictate the type of outfield distances you need. So orientation. So I'll just jump a little bit. The far right image you have here is taken from one of the FIFA design guidelines. It's just a rectangular field orientation footprint. Typically in the United States here in the Northeast and Northwest and everywhere in between, we want to keep in between a north-south direction, slightly to the north-northwest. When you're switching over to baseball, this little compass diagram is taken from Major League Baseball, kind of documenting all their major league facilities and kind of the orientation they have here. And as you can see, there's a lot of ranges that can happen, but primarily you want to be in the east to northeast orientation of it. So that's what you need to do. But the best way for the layout has to do with site constraints as well, right? Where's going to be the sun path and trajectory? Do you have woods in the area? Is it hilly? Do you have adjacent buildings that are prohibiting you from having the proper orientation? Things like that are in play. Surface grading here. So first we'll talk about rectangular fields. So in general, there's 3 ways to grade a rectangular field. The one to the left here is your traditional crowning, down the middle of the field, and then having a single plane from that crown in the middle, slope at a constant slope to each sideline. You form a ridge line basically from goal to goal. The second one is similar to the crowning. You're still putting a crown in there, but you're putting a crown in there more in the middle. Once you get a little bit past that, you are starting to slope to the end lines as well as to the sidelines at a constant slope, and you're creating what they call a turtleback. And then what you have here, sometimes the constraints don't allow you to do any type of crowning, in which case you can get away with a single plane. You go from one sideline to the other. It's into a side to side, if you will, and it slopes with a single slope there, constant grade. There is a fourth option if your site is constrained too much, and that has to do with like a diagonal from a corner to corner type of grading. However, that would only be recommended if the site constraints and balancing the site dictated you had to go to a diagonal, and then only if you had really good draining soils and were able to include some type of subsurface drainage system. That would eliminate you having to do a steeper slope, and you can get away with a minimal slope, so you have a better or less of an elevation change from one goal to the other. When you're switching over to baseball, baseball wants to be in the far right here. You can have a ridge line that would go through the backstop, directly through home plate, the pitcher's mound, through second base, and straight to the outfield, and then slope it from either side of that at a constant slope, side-to-side fashion. Or you can look at sloping the infield portion of it, having a minimal slope on the infield. Depending on the level of competition and the under drain system and the how fast it drains, you want to be able to go as minimal or as flat as you can on the grass infield portion of it. If you can get away with it being flat with great soils, that's great. But typically you want to stay around, I would say 0.5% in the infield area. And then when you transition into the skinned, the clay areas, you keep that at 0.5% as well. And then when you transition from that to the outfield and natural grass there, the one on the left is showing a radial pattern, and the one on the right is showing a side-to-side pattern. But you would keep that at a 0.5% to 1.5%, depending on the conditions that you have. So softball field is very similar. We are talking about doing the ridge line coming from the home plate through second and into the outfield with side to side, or we're talking a radial pattern once you leave the skinned area. The skinned area here is kept at a minimal at 0.5%. And then there is a third option that you could do if the site constraints dictated it, is you can do the skinned area in a side-to-side portion, but usually these two here is what is preferred. So this slide here is just a summary of what we have here. Depending on what the characteristics are going to be and what you're designing to, these are what the slopes are. Again, your in-field areas, your skinned areas, or you try to go as flat as possible when you can get away with it. Depending on whether you're putting subsurface drainage or no subsurface drainage, that will dictate the slope that you do in the grass areas in the outfields. And then rectangular fields as well. If they're crowned with no subsurface, you typically go at a higher slope. You can get away with that a little bit more with crown fields because you're not going quite as long as a distance. You're going half the distance as compared to the side single plane. So you can get away with a little bit more slope there if you had to, if you didn't have subsurface drainage. So this is just some conceptual kind of a little bit of extreme cases here, but you know, every site is complexity, and where are we designing, you know, a new construction. If you had to look at a situation here where your existing grade on the left was kind of a steep slope, and that was the area that you guys had to be able to put in some athletic facilities. Obviously, you have to look at balancing the site with cuts and fills and incorporating terracing, landscaping, or some type of retaining walls. And this is just what could be possibly done. You would do some sloping, some terracing, some retaining walls, and you'd be able to put fields as you kind of go through the existing grade to the proposed grade. So the installation of subsurface drainage systems. So there's different degrees dictating on what your in situ material is, your level of competition, and the area that that your facility is in, whether it's, you know, South Florida that receives deluges, or somewhere out in the Southwest that may not receive as much. So one of the ones here is the top left. That's a stone drainage layer that would go underneath your soil media and your turf grasses. It would be depending on what we're using it for, whether it's just for stormwater management or just to get drainage going out of there. Typically between 2 to 4 inch stone drainage media that would get bridged with the soil media on top. You can install flat panel drainage, which is the top right. These are drainage that goes in there shallow in a herringbone pattern throughout the field, depending on what your soil conditions are and how fast they drain. They're spaced usually, I would say, 15 feet on center. On average, they're about 20 feet on center for natural grass, but they can get spread out to 30 feet on center if you have good material there. So these things are laid down either flat and then top dressed with sand and then sodded, or you can use them vertically, which does even more minimal of a disturbance. We're talking 4 to 6 inch disturbance. A little small little trench digger like a ditch witch could do it, and then you would drop these vertically and then top dress it with sand. The only rule of thumb here is the top of these pipes or flat panel drains, you want to be mindful that you want to keep them at least 6 to 8 inches below the turf grass, because you want to keep in mind that in the future, when you maintain these grasses, if you have to aerate them with deep tines, and usually they're around 6 to 8 inches, so you don't want to be impacting these drainage that you put in there. The bottom left, what you see here is header pipes. So basically they're French drains, if you will, perforated pipe and stone, and they ride around the perimeter of your field, whether it's down the sidelines if it's a rectangular field, or along the outfield fencing if it's a baseball or softball field. And then the flat panel drains that are in the herringbone pattern ultimately connect to these header pipes for belt and suspenders to get the storm water off your field as quickly as possible. The bottom right is what you see here. It's a sand slit system. So basically, you're not putting any flat panels or any type of piping. You are creating shallow trenches and you're filling them in with sand. And the idea here is creating an area and a channeled system that's minimal disturbance and can give rainwater and stormwater avenues to drain off the field more quickly. So we have stormwater management here. So here's what happens. Okay, after we leave the footprint of your athletic fields, hopefully you have can get picked up with a perimeter grass swales you see here on the top right, and then you also have your drainage structures. These drainage structures are typically put in low areas, obviously, but in areas that are well outside the safety runout areas that we talked about before. You don't want to put these, and be mindful that these are not in the 10-foot minimum runout areas for safety reasons, obviously, for the players. These ultimately discharge, depending on where you're at and what the site dictates, into either your stormwater detention basin that you see here at the bottom left, or into some type of detention system. Right here, we're showing a subsurface detention system made up of chambers. These could be adjacent to the field. Some of them can be done under the field, or some of them can be done on another little bit down gradient, and they can have paved areas on top of it. They can be parking on top of it. They're very useful to be able to maximize the available land use you have in your area. Another big component, we're switching gears here to irrigation, right? How are you going to be sourcing irrigation? The first one here is city water, potable water, right? We're using city or town-owned water. One of the things you need to confirm is where is the nearest water main, what is the size of it, what is the capacity, what is its yield. You don't want to be, you want to be tying into a system that may be being used throughout the facility, has a low flow rate or a low capacity. If that's the case, you may need to install some type of booster pump and an adjacent storage tank to make sure you have it, right? You have the proper coverage to be able, your sprinklers and your rotors are able to get the proper distance and coverage that they need to function properly and get good irrigation. So water, because it's potable water, it's metered, and it can get costly depending on where you are in the region and what your water bill, what your rates are. So this is the extreme option, and I'll talk about some other options that we can get with. If you're fortunate enough to be able to have some good locations to groundwater, and you can get access to well water or a water source here, either a stormwater pond or adjacent water body that you can use for irrigation. You're using the water that's already on site. So by using this, you can reduce your need to use other irrigation sources, i.e. The potable water, right? And it would be ultimately less costly. You need to confirm the capacity and the yield of the well that you're installing. You need to get that a well contractor to get out there and do some tests, see what's going on and what you can get out of it. Depending on what you're trying to irrigate, is it one field, two fields, or more? Obviously, you may need additional wells, and similarly to before, you might need a booster pump and storage tanks and things of that nature. The photos here that you see here on the top right and bottom right is a baseball complex that's been down in the Fort Myers area for Major League Baseball for spring training facility, and it's utilizing a stormwater pond next to it. And it's what you see here in the bottom right is, you're using that, but depending on whether you've had a recent rain event to that stormwater pond or something of that nature, you will need to include some type of maintenance and filtration and sediment devices within that system, so you're not clogging causing any damage to your irrigation heads. The other type of system that's, if you're fortunate enough to be near a stormwater reclamation and water reclamation facility, you can get, usually those are designated by these purple water lines you see here. They will greatly reduce the need for other irrigation sources like potable water or well water. The reclamation facility, it's still costly to try to process this water, but there are a whole slew of incentives that the municipalities put in place to make it more affordable than potable water at the end of the day. Again, depending on what the condition is, you may need a booster pump similar to everything else, and you have to check the chemistry of these. Depending on what it is that's leaving the site, it might be high in some nitrogen or phosphorus. It might be the pH level might be off. So you want to check if you're going to be using reclamation or reclaimed water. You want to make sure what the chemistry of that water is, because that will affect how you do your own fertilization amendment as you maintain your natural grass. And then a little bit of lessons learned here, but not all reclamation facilities are created equal, and some of them don't have really top-notch filters, and they can get algae or suspended solids. Usually 9 times out of 10, it's microplastics. They get through that system, and if you don't have some type of filtration system on your end before you discharge this reclaimed water, over time you can clog and damage your own irrigation heads and cause more business. So the last one before we move off irrigation is stormwater harvesting. It sounds great, but may not always be the best fix to your area, depending on where you are in the region, the amount of irrigation, how often you need to irrigate, depending on where you are and the type of turf grasses you're going to be using. You may need to have very large storage systems, or this may be a combination of using this and then using some type of well or reclaimed water or potable water that will go with it. So selecting the growing media for turf grasses, we have your native soil. That's the minimum. That's basically, you're creating the fields. You're going to use what's there right now. You will take it. You will scrape it off, stockpile it. You'll grade out the area for the field, and you'll bring back this native soil and laser grade it and use that. Then we have your modified soil that can get in there. So basically, similar, you're using the native soil, but you're modifying it with different levels of organics and sand as needed to create a better growing material. And then you have your sand capped soil, and then you have your sand based root zone. And I have some graphics of that. So the graphics of that is on the right here. The top one to the right is your natural and native amended soils. So on these, like I said before, we're talking about amending it with some sand and organics and better growing media. But ultimately, they do, because they're native, tend to drain slower than the other two. The other two are a little bit more on the high end, more higher level of competition. One is the sand capped, which is basically on average you're replacing 2 to 6 inches of the top soil media, and you're replacing it with a sand media, very heavy in sand, typically around 60 to upwards to straight sand, 100% sand. And then you have your sand-based root zone. Typically that comes into play when you're including an under drain system with that, and you have on average 6 to 12, but typically it's 10 inches of a sand-based system, and then your sod on top of that. Your mix comes on top of that. So the other part is, where are we talking about, right? Where are we located, right? You have your warm season grasses that are in the southeast and Texas, in the Texas area, a little bit west. Then you have your cool season grasses, which is up north, northeast, and the northwest, and then you have your transition zone. And the way they explain it to me in the transition zone is it grows it grows all types of turf grasses, but not one particularly well. So you just got to be mindful what has typically been successful in your area, and use those types of turf grasses, right? Typically in the warm areas, we're talking primarily Bermuda, and in the cold areas, we're leaning more toward Kentucky Blue, and then mixing it with different types of rye. So different types of turf grasses, depending on the seeding and the vendor and the manufacturers are different. They're cultivated for different things. One is whether it's durability, water requirements for irrigation, drought tolerance, level of maintenance, right? Can they repair themselves well, or do they need to be managed with limited use? And then there's the seeding versus the sodding, right? Sodding, you typically can get on it much quicker as soon as you can establish a good root growth. Typically, that can fluctuate anywhere between 45 to 90 days. If you're seeding it, it's going to take much longer to get established. And you're typically looking at probably 2 growing seasons to get a good establishment on there. All right, we're talking a little bit in construction here. So construction, first, some of these photos that are kind of give you a sense of what's needed. The one on the top right is kind of the main one that once you move everything around. These are the laser graders, and this is what dictates. You're not doing kind of general landscape areas here. You're doing high level athletic facilities, so you want to be able to have the planarity that you need, a consistent slope. And the one here is shown for baseball, which I talked about previously. The infield and skinned areas are pretty flat. That flat, if you can get it with good under drains, up to 0.5%, and then the outfields are typically drained at 1% or less, right? So the installation of your stormwater management. So what you're doing here is you're installing your stormwater around the perimeter. What you see here in the bottom right is your perimeter pipe and stone. Typically, this is what gets done in all the natural grass fields, whether they're baseball or rectangular multi-purpose. They're basically framing the field, if you will, running around the perimeter, and your flat panel drains or any type of subsurface drainage or drainage layer ultimately connected as to have one system, right? Concurrent with that, you're installing whatever irrigation system you're going with, and you're installing the lines so they're not conflicting with the subsurface drainage lines, and you're installing your turf grass profile. For example, if this is a native or a native and amended soil, you would be, removing it, stockpiling it. You would be amending it based on what testing results were and the recommendations, whether it's adding more organic, any type of nutrients to it, the right amount of sand to create the best growing media you have, and then you're placing it back down, you're laser grading it, and then you're the sod versus seeding and your growing period. So this is a photo of a baseball facility in Florida where they were having some issues with some turnover in the facility managers, and just let it lax over time, and wanted to bring it back to the tournament high level performance that they used to have. What you see here in the photo on the left is basically they were not doing that well of a job, and over time the addition of clay mix and skinned area caused that elevation change, and they weren't to grow drastically, and they weren't doing a good job transitioning from the skinned area to the natural grass area. And over time, that built up a lip, and it built up the clay area. So where the arrow is pointing, it's a little bit difficult to see, but once you step off that clay area, there was a sharp slope and an elevation change of close to a foot. So, and it was really close to the baseline as well. So it was causing a big safety concern. The athletes and the baseball players were, trying to get the balls and run around and not keeping their arm. They don't want to keep their arm on the ground, and a couple steps off to the left, and they're tripping all over the place. What you see here in the top right is the areas there where skinned infield area was very minimally sloped as it was supposed to, but the native soil underneath there was and the thatch buildup over time of the turf grass was very slow and causing it to pond and stay wet for extended period of times. And then some of the other issues here is when you got to the outfield, there was a very again like a hump, like a large lip between when it transitioned from the outfield into the warning track, and over time that warning track had reduced in size. It was getting close to about 6 feet now, where originally it was at the recommended 15 feet warning track length. So there was issues there that they needed to take care of. So at the end of the day, this is what happened with the results after. This was to get this done, they did not want to just do a Band-Aid approach. They wanted to reconstruct the whole baseball facility in kind. I'm not showing you here the ancillary things that were included to the backstops and the tension netting systems and things like that, and dugouts. But the baseball field here was completely scraped. It was stockpiled. They still used the amended soil, but they amended it. But they did include new subsurface drainage system throughout the whole field, and then re-laser graded the whole thing. So it came out to be a success. They installed, scraped off and installed the larger safety runout area, and it's performing as it was originally designed. So touching base on maintenance. So these are some rules of thumbs for maintenance, right? And just starting talking about these briefly. How is the field being maintained, and how are we maintaining it per the intended sport, right? Typically, if you're doing soccer, if that's a dedicated soccer field, if it's not shown here, but if it's a field hockey field, especially natural grass field hockey and lacrosse to some extent, they want the cutting heights shorter for a faster ball roll, playability and performance with the ball. If you're talking football, you can get away with a higher cutting height for that, right? So it all depends on what's the sport. Is it going to be a true multi-purpose, or is it going to be a dedicated venue for a specific sport? And then one of the often ones that get that cause problems is the repetition of coaches and players wanting to practice frequently in the same area of the fields and not rotate around. So they'll move the practice goal or the lacrosse goal to a certain area, and they'll just repeatedly use that for practice over and over and over again. And it's just not the piece of grass, the turf grass that's underneath there cannot be sustained because the athletes are just killing it. So you gotta be mindful with that. You gotta get it into their heads and have a good system in place where they can actually rotate it around to give your areas a chance to recover. Continuously assessing the soil conditions, your moisture levels, your pH, nutrients. Just keep on top of that and having a good log and monitoring it so you can be preemptive instead of reactive, right? And then, do you have the proper equipment? Is you have just mowers and spreaders, or do you actually have the aerators and the verticutters and things like that? And if you don't, are you budgeting to purchase them and procure them? And if not, are you at least looking at contracting it out to others to at least get some of these in throughout the year, so you can maintain your facility? And then the last one here is one of the most important ones, right? And the one that gets overlooked a lot is having a legit, real inclement weather policy with one person in charge to designate a person who gives the final, yeah, this field is soaked, it's a go, no go, you can't play on it, it has to recover. All it takes is one wet football game, one wet lacrosse game in the late fall or early spring, and you've destroyed your field's root zone, and you're now in repair mode. So that's one of the ones that we really try to push on, and one of the first ones when we look at facilities and we talk with the facility managers and the staff is, all right, what's your inclement weather policy, and who's in charge? So these are just some just kind of rules of thumbs and kind of talking about what kind of maintenance, right? I talked about it before, is aeration and sand dressing. That's the photo on the bottom right. Your natural grass fields will get compacted over time, especially if they're native soils, and that will over time not only increase the compaction, will increase the hardness and cause a potential safety concern for athletes with impact attenuation, but also slow down drainage vertically, and not being able to get drainage into the subsoil, into the root zones for that matter, and not being able to have air voids and the roots can be ventilated as well for proper growth. And then your field kind of switches over and relies straight on surface drainage to the sidelines. So using a deep tine and a hollow tine, where you see these things on the bottom right, is they're going in 6 to 8 inches, and they're removing whole plugs of that soil media, and then you come back with it and you top dress it with sand, and you're creating avenues there to decompact it and to improve the drainage and the growth quality of the site. Verticutting is something you see here in the middle here, and talking about it. You're going in there, and you're over time, your turf grasses build up a thatch layer, and you got to get rid of the thatch layer for similar reasons to aeration. You want to be able to get a proper growing media. You want to be able to get good nutrient absorption down to the roots, and you want to be able to get better drainage through there. And vertical cutting too actually helps the grass blades themselves kind of stand up more and grow more vertically. So there's different types. Warm season grass, you tend to do this in the springtime. In the cold season, you tend to do this in the fall. And then in the far left that you see here is just a show of the sand slits that can go on. So sand slits is a quick and easy way to introduce drainage flow patterns into your field, and to be able to get water off the field as well. If we're having issues with aeration and compaction in native soils, and we don't have a good robust under drain system, and you don't want to take your field offline to make these repairs, doing the sand slits is a good compromise. So these are some options that were taken from the Sports Field Management Association. If you go to their website, they have they're a real wealth of knowledge. They have a whole database and clearinghouse of recommendations for all types of conditions. And what you have here, the first one is kind of the graph that's coming in from the annual kind of cool season maintenance overview. It kind of shows you the months that this type of maintenance from mowing all the way down to disease control would be happening. I tried to color code these a little bit just to stand it out a little bit. So what you see in the yellow is the optional. It depends on what you're getting, what your test results are. You don't necessarily need to fertilize them, throughout all these months, or use the regulars or the cultivation. It can be done during one of these months if your results and recommendations come from that. And then what you see in the blue is the areas that are weather dependent. Obviously, cool weather, you're dealing with winter and freeze thaw and things going a little bit dormant, and you're not necessarily mowing in December when you might have a foot of snow on the ground, things like that. The next one here is your warm season maintenance, and is just specifically tailored for the South and the Southeast, and it has similar things. There's things that are optional, and there's things that are weather dependent. You're not having your snow, your freeze thaw, not necessarily, or for a shorter period of time, but you're still, you're mowing. You might be mowing less frequently in those months. One thing that has come up, and it's kind of new, or at least new to me, is we're getting a lot of complaints or concerns with reoccurring and continuous painting and marking. And this is specifically in areas where you might be painting a logo, or in the football field, you might be doing a wholesale kind of graphics, painting the entire end zone, or putting large letters, or putting very large borders around the playing areas. So what they're finding, and several universities are trying to do a little bit more tests, and the Sports Field Management Association is looking into it a little bit more, is whether it's the chalk or the temporary paint that you're doing, the layers that are going there are now over time going to the full depth of the growth media. So that's affecting the way the area that's being painted drains. So you're getting much lower infiltration rates in that area. So you might be free draining to the left and right of it, but once the athlete steps on that one, it's still a little mushy, because it's been decreased from all the paint layering that's in the soil matrix now. And then the other ones is it slows down your growth, the optimal growth in your root zone growth depth, but also it could have an effect on the shear strength. So what I mean by shear strength is when the athlete plants their cleat down, areas that have continuous layers of paint can have a much less shear strength. So that means when they plant down, they're getting little to no resistance from their cleat, and they're just losing their foot placement from under them. So that can be a concern and a safety issue as well. So lastly, I'm going to just wrap it up a little bit with some order of magnitude budget costs, and these are some expected costs. Now, what we have here is kind of a sample chart that's coming from the Sports Field Management Association of kind of annual maintenance. Again, these can be more or less depending on what your facility is and what your needs are and what your existing conditions are. But on average, for constructing a natural grass field, we're looking at around $390,000. Now, there's many variables in that, right? Again, what are we putting in there for under drainage? Can we get away with just native soil amending it? Do you have to do something a little more extensive? Do we have to balance the site a little bit more topography? So we've seen brand new natural grass fields come in with in the $250,000 to $300,000 range, and we've seen them come in the $750,000 to $800,000 range. So it all depends what we're talking about here, and then the cost to maintain these fields, whether they're rectangular or ball fields like baseball and softball. On average, we're seeing around $33,000 annually to do what we're talking about to the right, and this is this is prefaces by saying to have a well-maintained performance field, right? If we're using this only for some practice purposes and not really game field ready, we might be doing a little bit less maintenance on it, right? If we're doing native or sand-based would require more because, you know, it's sand-based, that's great. You have a sand layer in there. It's draining like a champ, but guess what? It's also needs now more irrigation. It needs more nutrients because they're not staying in the soil media as long as they would with other type of material. And then the type of irrigation you have, right? Like I talked around before, if you have a pristine game ready field with all the bells and whistles, but you're using unfortunately city water, potable water, your irrigation and your water bill is going to be through the roof, as opposed to having a system that can benefit from some type of on-site well or anything like that. Okay, so with that, I'm wrapping it up and open to any questions. And as we said before, as Billy said, if there's anything else that is more detailed and getting in, I didn't want to get too much into the weeds, we can definitely reply to you online or through email. Thank you.
Okay, Pete, we do have some questions. I just want to let everybody know that we will have the slides available. So when you get your follow-up email tomorrow, one of the questions will be is, do you want a copy of the slides? So just respond to that email back to me and we'll get you a copy of the slides. So our first question is, what type of subsurface drainage solution was chosen for the baseball softball field in Florida just covered?
Sorry, I was muted. So yes, for the baseball and softball field in Florida and some of the images that was chosen there. So what they chose with, it was Florida. So fortunately, Florida has a little bit better free draining soils. Their problem was their planarity and their overall kind of growth issue. So what they chose is to go with their native soil. They tested it, they amended it with some additional sands and some more organics and placed that back down. But they went back with the perimeter header pipe, perforated pipe drainage system down the baselines along the backstop and down the outfield line, and then space the flat panel drains at 20 feet on center throughout the whole field. And that was the solution there. The sloping of the infield was at 0.5%, and once they got to the outfield, they chose to go with 1%.
Okay, thank you. Our next question is, do you have an inclement weather policy template?
Yes, we have a template that when we do some type of feasibility studies and master planning that we use. The industry that I talked about before, the Sports Field Management Association, they have a great template as well that they use. We can look at sending you a sample of it. It all gets dictated to it gets tweaked per the owner and what they want to see. But the key takeaway from the inclement weather policy is who is the person in charge and who makes the call, not having too many cooks in the kitchen, if you will. Whereas one person says, no, we can't play on it, but another person told them, yeah, you can play on it, and the team went out there,
Okay, thank you. Well, wait, okay. Another question just came in. How do you recommend dealing with weeds such as dandelion with using a weed killer?
Yeah, on that one, I'll email you the answer to that one, because we've been kind of moving a little bit more away from the chemical additives for that for weed killing, and trying to get to a more environmental kind of approach on that. So there's some there's some good recommendations from Sedator Managers Association that we can definitely send you for that.
Okay. Well, just want to say, Pete, thank you so much. I'm getting lots of requests for the presentation and positive feedback. That, you know, your slides and everything were fantastic. So thank you very much for taking time out today to be with us. And as always, to our attendees, thank you for taking time out of your extremely busy schedule to be with us. So if any other questions come in, you can send them to me at Billie, BILLIE @appa.org, and I will forward them on to Pete and to Karen. And to both Pete and Karen, thank you so much for the presentation, and we look forward to our next presentations.
Thank you.
Thank you. Bye-bye now.